Hello everyone, welcome to our discussion on the inverse of a function from the chapter Algebra in our IGCSE syllabus. Now, in order to establish what the inverse of a function does and what it is and how to obtain it, we will start out with a simple function f of x is equal to 2x minus 3. And the inverse of the function f we will write as f to the power of minus 1 of x. And we shall see how we establish the inverse of the function f. For this we need to go back to maybe year 9, where we had a different way of writing these expressions. We wrote them as y is equal to 2x minus 3, and we called them straight line graphs. So we have assigned f of x the name y. In order to find the inverse of the function f, we need to find the function that basically undoes the effects of the function f. So what we will be doing is we will be making x the subject of this identity. So let's start. If 2x minus 3 is equal to y, that means that 2x is equal to y plus 3. And if 2x is equal to y plus 3, then x will be equal to y plus 3 divided by 2, which we write as y plus 3 over 2. What we have obtained is an identity where now x is the subject. We've basically retraced our steps to making x the subject. What we have obtained therefore is the inverse of the function f. So then if we go back to f to the power of minus 1 of x to the inverse, the variable is x, so we will no longer be using y. We will say that it is equal to x plus 3 over 2. This is how we find the inverse of the function f. So let's recap. F of x we write as y, and we make x the subject. Once we have made x the subject, we find the expression for the inverse of the function f. So f to the power of minus 1 of x, the inverse of f, is x plus 3 over 2. Let's see a little how this works. Say we take our function f of x is 2x minus 3. That means that if we give a numerical value to x, let's say 2, then f of 2 will be 2 times 2, which is 4, minus 3 is equal to 1. So when we give x the value of 2, the function has the numerical value of 1. Now what happens in our inverse? When we give our inverse the value of 1, we will get 1 plus 3 over 2, which is 4 over 2, which is 2. So in our function f of 2 is 1, and in our inverse f to the power of minus 1 of 1 is 2. The function attributes to x the value of 1, and the inverse reverses that effect, attributing to 1 the value of 2. Now, how to verify if our inverse is correct? So how to, much better, verify our result? Well, we have here a specific property that basically tells us that the inverse undoes what the function does. And that property is that the composite between the function and its inverse will always be equal to x, which x is actually the identity function. So every time we do the composite between f and its inverse, we should get x. In this example, let us have the composite f of f to the power of minus 1 of x is, we replace in the function f the argument x, the variable x, with f to the power of minus 1. So we will not have 2 times x, we will have 2 times, and f to the power of minus 1 is x plus 3 over 2, and further on minus 3. We have replaced, again we say it, x with x plus 3 over 2. What do we get then? 2 and 2 we can simplify, so we have x plus 3 minus 3. 3 minus 3 is 0, which is equal to x. Also, we can add here the fact that it doesn't matter whether it's f of f to the power of minus 1 of x or f to the power of minus 1 of f of x. The result should be the same, x. Let's see this in action. F to the power of minus 1 of f of x will be equal to, in f to the power of minus 1, we replace the variable x with 2x minus 3. So we will then have 2x minus 3. Further on we had plus 3 over 2. Minus 3 plus 3 is 0, so we have 2x over 2, which is equal to x. This is how to verify if our inverse, the inverse that we have obtained, is correct. We can always do this after finding the inverse of a function. So once again, how to find the inverse of a function f? F of x we can write as being equal to y, and then we make x the subject. Once we've made x the subject, we found the expression for the inverse of the function. We can then verify knowing that the composite between f and its inverse should always be equal to x, the identity function. Thank you very much, and have fun doing mathematics. Bye bye.